Hello students, welcome to We Teach. So in this session, we will cover what is overfitting. Suppose consider you have a supervised data set, and on that supervised data set, we are using decision tree classification algorithm. If your tree gives minimum error with your training data set and gives maximum error with your test data set, then we can say that your model is overfitted. So we will see what is overfitting and how to overcome overfitting here, right? So coming to the definition of overfitting here, suppose consider you are given a hypothesis space H, that is you have a hypothesis space for ID3, right? So you are given a hypothesis space H. Now in that hypothesis space, pick any two hypotheses H and H dash, right? So a hypothesis H belongs to H is set to overfit. So now H is set to overfit the training data set. This is the training data set that we consider. Now your H is said to overfit this particular training data set if there exists one more hypothesis called H dash, which also belongs to your hypothesis space H, such that H has a smaller error than H. When this particular H is giving less error rate on the training data set and more error on test data set. So we already know, right? So whenever you're in any machine learning algorithm, you will be splitting your data set into two parts. One is the training data set and the other one is test data set. So now when do you say that a particular model is set to overfit? When you consider any two hypotheses H and H dash, if one hypothesis will give less errors compared to other hypothesis on a training data set, but your H dash is giving small error than H on the entire distribution of instances. So on the training data set, this particular H is giving less error on the training data set and more error on the test or overall data set that we consider, right? But if you find any other hypothesis H dash such that this particular H dash is giving less error on the overall data set that we consider, but your H is giving less error only on the training, on test it is giving higher, right? So if you find any other hypothesis like this, then we can say that this particular H is overfitting. So overfitting, what do you mean by overfitting? Now consider a hypothesis space. In that hypothesis space, select any two hypotheses H and H dash. So H is giving less error on the training data set and the same H is giving more error compared to H dash on the overall data set. Then we can say that H is overfitted, right? So that is what is mentioned here. See here, consider the error of the hypothesis over as on training data, let the hypothesis error be like this. Let us represent like this, error of H train, and on the entire data set D, let the error be represented like this. So now when do you say that this H is overfitting the model? Hypothesis H belongs to H, where capital H is a hypothesis space, overfits training data if there is one more hypothesis H dash which belongs to the same hypothesis such that training error of H is less than training error of your alternative hypothesis H dash, and training error of H on the complete data set is more when compared to error of H dash on the entire data set. So then we say that this particular H is said to be overfitted, right? So this is what is called overfitting. Now what we need to do, we need to just reduce the problem. The problem here that we come across is overfitting. So now we need to reduce this overfitting problem. We have to overcome the overfitting problem. So this is the diagrammatic representation of overfitting. So see here, this is your training accuracy that we got with your training data using decision tree model, and this is on the test data. When you observe, when the number of nodes are increasing, that is when the size of the tree is gradually increasing, what happens? The accuracy for the training is increasing, but the same model is giving less accuracy on test data set. So then we say that this particular H, let the hypothesis be H here, then we say that it is overfitted. That is, any model that fits your training data completely but does not fit your complete test data set, then we can say that this particular model is overfitted. So what do we do for this? The major reasons for overfitting is, one reason is maybe because of the presence of errors or else noise in your data. Noise means instead of one value, instead of one label, you may have another label. That can be considered as noise here. And the other problem is, whenever you are dealing with the instances of your training data set, so during that process, we will be finding only less number of instances. Using less number of instances, we have trained a model, and this particular model may not fit the new set of instances of the entire data set. So these are the two reasons why we may get a overfitted model. One reason is having error or noise in your data set is one reason for overfitting, and the other point that is the reason for overfitting is, if you are considering some set of instances of while constructing a decision tree, if we consider very less number of instances while constructing a tree, then we may have, if that particular instances are not available, if we don't come across such instance in a test data set, then also error may be more. So that may also be the reason for overfitting a model, right? So this is one of the example we consider for noisy training data set. Suppose consider this is the decision tree that we have generated for a given data set. So in this decision tree, what is the condition here? If outlook is sunny and humidity is normal, then the class label is yes. Similarly, if outlook is rainy and wind is strong, then the class label is considered to be no, right? So now we will consider a new instance which is not present while training this particular decision tree, right? So let the example be like this: sunny, hot, normal, strong, and the class label is negative, that is no here, right? So what is this? Sunny, overcast is sunny, that is like this will come, and humidity is normal, that is like this we come across. What should be the class label here? It is yes. But what is the class label we are having here? Negative, no. So there is a mismatch. So there is mismatch between the class label. So we say that this particular model does not fit this particular 15th instance of your training data set. So this is the noise that is present in your training data, or else the overall sample that we consider for training. So instead of plus, we have minus. So this can be considered as the error or noise present in your training data. So because of this particular tree, this tree is misclassifying the given 15th instance. So this is what is called noise. Due to this, we get wrong results, or else we will be misclassifying the instance. So this is a problem. So what do you do in order to overcome that overfitting problem of your decision tree? So now we have two methods. One is pre-pruning, which avoids overfitting, and other solution is post pruning. So what are the approaches we use? The approaches that are used to avoid overfitting in decision learning is pre-pruning, that is before we completely construct a tree, we start. Prune means cutting, like removing, you can call like that. So right, so while constructing a tree itself, we start cutting the tree or else branch which misclassifies my data. So that is called pre-pruning here. So with the help of pre-pruning, we avoid overfitting. So we reduce overfitting so that we will not have any problem when you classify using a tested data set, right? And what is the second solution we have? Post pruning. Post pruning means let the decision tree be completely constructed. Let me construct the tree completely, and then we start cutting the branches so that this particular final tree will not overfit the new data set, right? So this is recovery. This is used for recovery. So once we have already constructed, and if we feel that this particular model is overfitting a new data set, then we start cutting the branches which misclassifies the data set. So these are the two methods that we use to avoid overfitting problem in decision tree algorithms. So how do you select the best tree now? Okay, I have many trees in your hypothesis space, but how do you select the best tree? So one is you need to measure the performance over training data. Suppose consider already have generated a tree, already tree is constructed using some training data set. So how do you select best tree? In my hypothesis, suppose this is my hypothesis space. In my hypothesis space, I almost have 1,000 decision trees. So from this 1,000 decision trees, I need to pick the best tree which does not overfit the test data set, right? For that, what we do is we continuously measure the performance of this particular tree on a training data, point number one. Second one is we also measure the performance of the same tree on the tested data set, and during this process we should continuously check this particular formula. What is that? Size of the tree. We should always minimize this value. What is MDL here? Minimum length description length. That is, we already know, right? So during inductive bias, what we discussed is you need to select small trees rather than long trees to select the best tree here. So for that we need to pick the tree which is having MDL minimum, right? Minimum description length should be very less. So this is the formula in order to calculate MDL value. So every time you need to construct a tree, you need to check the performance of the tree on a training data set, and you should also check the performance of the tree on the validation set. So this process should be continuously done, and in the middle you need to perform pruning process, right? So construct a model, evaluate the performance over the training data set. If you feel there is any problem, or else if you feel that there is any misclassification, start doing pruning. Again, a new model you will get. Now apply the performance, calculate the performance of that, and then finally test on the validation set. Again, if you feel you have a overfitting problem, this process will continuously happen until you get a final model, so that this particular model is not overfitted, right? These are the different approaches that we have for avoiding overfitting. So in the next session we will cover in detail about what is this pre-pruning and post-pruning.